Geotrig, this is lesson 11, and what we're going to talk about today is circles. So, today we're going to talk about what a circle is and different parts and pieces of circles and their properties. It's only a couple slides long, and then when we come back tomorrow, we will do examples that'll finish together the idea of what circles and some of their properties are, and then if we get lucky, we'll actually start going into the quadratic formula. So, day one here, we're going to talk about a circle, and guys, a circle, obviously, are those things in the bottom of the page that we have here. Those are 5 circles. The definition is not necessarily just a round shape. It is the locus definition, guys. It is the collection or all of the points in a plane that are equidistant, same distance, from a point called the center. And so what it means is that once you know a fixed point at the center, I'm using the bottom left circle there, that if you put a dot in the middle, everything from here is all the same distance away. Granted, my drawing is really crude right there with my radii. So, each one of those red lines is called a radius. A radius, guys, connects the center of the circle to its sides. Or side. Not more than one, just one side. So, that is a radius. The red lines here represent many radiuses. We don't like to say radiuses, so we say radii. Okay? Radii, it's rad, R-A-D-I-I. Radii. So that is for plural for radius. Okay. So the first circle, that's what we're using for radius. The second circle is what we're going to use for a chord. A chord, ladies and gentlemen, is a line segment that connects 2 points on the circle. So any 2 points on the circle connected with a straight line creates a chord. So in our drawing, if I connect these 2 points on that circle, I have a chord. And there is a very special chord that happens to pass through the center of the circle, which in this case I'll denote by a large red dot. That is the diameter. Now that's called a diameter. It is a chord that goes through the center, and it happens to have the length of
2 radiuses.
2 radii. So 2 radii. So it has 2 radii as its length. The diameter is equal to 2r. Does that kind of make sense, guys? You've done this before. You've seen this. And so, we can move on to secant. It's a line that intersects a circle at 2 points. Whoa, wait a minute. That does seem to sound very familiar for secant and a chord. What's the difference? What is missing from secant that chord has? Third word. Segment. So a line segment starts and stops. A chord
and connects.
A chord, guys, starts on the circle and stops on the circle somewhere else. A secant will actually starts outside the circle, finishes outside. So technically, I guess it could be a line segment in itself, but it would have to extend past the circle. That is a secant. Is everybody kind of okay with that?
Yes, sir.
Then we move on to tangent. The tangent is a line that intersects a circle or touches a circle only once. So, that is a tangent line. That is tangent to the circle. Okay? So if I'm tangent to the circle, I am touching the circle in one spot. Here's a really cool thing. I think we have to take note of this because we will use this to our advantage. Would you guys agree that the center of the circle is give or take there? That purple dot? Somewhere around there. What if I connected straight up to here? What kind of angles do you think that's forming?
90 degrees.
It is 90 degrees. A tangent line forms a right angle with the radius of the circle, I guess. Not a circle, but the radius is perpendicular to its tangent at a given point. So, perimeter. Perimeter is also called what? Circumference. It's circumference. And how do I find circumference? What's the formula, guys? Some of us know. Not something with pi, yes, but not pi r squared, that's area. Pi r, oh, not pi r squared, wow. 2 pi r. It's 2 pi r is the circumference. 2 pi r. That's how you find the circumference. You actually can find pi, and this is how they did it way back in the day, is they took a circle and they found the diameter of the circle, and they also could find the circumference of a circle. And if you take the circumference and divide it by 2r, which is diameter, you end up with pi, which is 3.14 la-di-da-di-da. Okay, guys, big stuff here.
Arc.
I have a circle, yes?
Yeah.
With a center.
I would hope so.
What we can do here is I can connect the circle to the outside. It looks kind of scary here. Okay? This, ladies and gentlemen, oh, I don't like that.
Disgusting.
Okay, hold on. We need to, oh, it's a highlighter, that's why. I wanted this one. There we go. This right here. Oh, that's crazy.
That's massive.
I didn't realize that was going to happen. I don't like that either. Let's go this one. This is what I wanted. There we go. Okay, guys. This thing right here, that highlighted deep red there, that is called an arc. Okay? So this is an arc. An arc, guys, goes from 2 points on a circle. So I could have point A and point B. If I connect those 2 points, I will have an arc. Okay, now we got a problem. I got a kind of a problem here, guys. Because if I was to poll most of or everyone in this class, or even go further out into the real world, maybe even go down to like third graders, people who have never seen this stuff before, and I ask you to connect the points A to B, right? A and B. Follow this. Most of us would take the path of least resistance. No, well, I'm going to follow around the circle, say. Okay?
Oh, okay.
Most of us would probably do arc AB as right here, right? Because it's the quickest way, get it done, or walk away. But we all know that there's going to be that one kid that would go the long way around, right? But here's the thing. That kid would not be wrong. Guys, this side over here is also an arc.
Yes.
From A to B. So here's our problem. There are two arcs. One of them happens to be the major arc, and the other one happens to be the minor arc. The major arc, guys, is the bigger one. Major arc. And the smaller one ends up being the minor arc. Most of the time when we're dealing with arcs and angles, we talk about the minor one. It's the one in question. But don't forget that if you call this something like 80 degrees, there also is one on the back side of 280 degrees. Because they have to add up to what? 360. Okay? Now, here's a kind of a cool thing. A semicircle. A semicircle, I'm going to move to the top, is basically half of a circle. It's 180 degrees. Now, if you think about it, there should be a bottom half to that semicircle. I personally wouldn't call a semicircle a major arc or a minor arc. Is that okay? Because they are the same. So, I would not call it major or minor. The other thing we have to talk about is 80 degrees. 80 degrees or 280 degrees, they're at the center of the circle. Those are what we're going to call central angles. Central angles are angles that are formed by two radii connecting the endpoints of the arc to the center. Notice a line is drawn from the center to A, the center to B. Those two radii set up 80 degrees. Bless you. It also sets up 280 degrees on the other side. Central angles are at the center. You have to be at the center to be a central angle. Big note here. Double starred here, right? The angular measure. So this is not the size of the length of the arc. It's the angular size. How big is the angle that goes to that arc? Is the same as its central angle. So if I'm talking about 80 degrees is the central angle to the red arc, that red arc has an angle size of 80 degrees. The flip side, that's in purple of 280, its intercepting arc is 280 degrees. Does that kind of make sense? The arcs, major or minor, take the same degree as its central angle. It's going to help us solve a couple problems. And all the central angles added up should equal 360, just like all of the angles or all of the arcs should add up to 360. Makes it pretty nice. And of course, the last thing here, guys. If we take a look at this diagram and I say that that has a 10-inch long, or 10 inches, or 10 units long for its radius, and I draw another circle with the radius of 10, what do we say those two circles are?
Congruent.
Because they have the same radius. The only identifying attribute about circles is its radius.
What about diameter?
The diameter is based off of
The
radius.
Okay.
So if the radius is 10, the diameter is 20 on both of them. The area is the same on both of them. The circumference is the same on both of them. It's enough to state they're congruent. Okay, last of our notes for today, we're going to talk about inscribed angles. So for an inscribed angle, I'll bring back the circle. Here's a really cool thing. Actually, I don't need the center of the circle. if I denote that from A to B, there are 80 degrees of an arc. Okay? So maybe if we want, that means that the central angle is what? If the arc is 80 degrees, the central angle is
280.
80 degrees.
Oh, for that.
Then the other one is 280.
Okay, so we're not going to worry about that for now. But, watch this. What if I took the angle that was at the center, right there, and I pull it back to a single point on the circle? What is the measure of this angle?
80 degrees.
It is not 80.
70 degrees.
It is equal to 1/2 the
40
measure
degrees.
of the intercepted arc. It is
40 degrees.
No, I already said that.
40 degrees. Why is it 40 degrees, guys? This
Because it's half of it.
is half of the arc. But guys, guess what? Look at this. Watch this. What is
The other
the...
half
It's half.
20 degrees.
It's not 20.
is 40.
It's still 40 because look, this angle opens to A and to B, which has how many degrees? The arc is 80, so that means the inscribed angle is
80. 40.
40 degrees.
What?
No matter, as long as they come from both A and B, no matter.
Yes.
It's going to be half.
Do you guys see this? Pay attention. As long as the angle opens to A and B, it will have to be
Half.
half of it. So, I got a question for you then. What if I went this way? How big is
Double it.
that angle?
160.
Is it 280? Do you have it? Oh.
No.
I got a question. This angle, which is
It's less than
this one, right?
Yeah.
It is opening from A and B, right?
Oh, so it's
Yeah.
But which way is it opening?
out.
The opposite.
It's opening to this side. How big is this arc? So this arc was 280. So what's half of 280?
140.
It's 140 degrees.
Is this drawing?
If I put this as 50, what's this arc?
Which one?
If this
Oh,
is
it's
50,
100.
it's 100. Do you guys see this? Because the inscribed angle, which is at the back of the circle, is half of this arc. So therefore, 50 times 2 is 100.
100.
Inscribed angles are half. That means the intercepting arc is twice the inscribed angle. Now we can talk about this circle. Do you notice that I got a chord here? I've got a chord here. And they're crossing inside the circle. This is really fun. This is really cool. I think so. So it must be. The four pieces that are broken up, basically, the pieces of one chord get multiplied together will equal the pieces of the other chord. So x, y equals PQ. So if you were given 3 out of the 4 parts, you could solve for the fourth one. Is that cool or what?
That's pretty neat.
We'll put that to practice tomorrow, not today.
Okay.
Also, this is something we're going to assume true without the proof. But the last one, I'll quickly go through a small proof with you guys to help you guys out with this one. Guys, if two tangent segments originate from a single point outside the circle, and these are now tangent, that means M will equal N. They have to be equal. Here's the reason why. Whoops. The reason why. Would you guys agree that the center of the circle is about there? This would be tangent about here and about here. Is that okay? Could I connect and make your radii? Is that okay? Is it okay that if I connect the center of the circle straight out to the... What does that form?
Triangle.
Two triangles, yeah? We learned something about tangent lines. Tangent lines form what kind of angles to their circles and the radii? Right angles. So we have right triangles. Hey, I'm assuming this line down the center that's shared must be the same. What's the reason again?
Oh, shoot.
Reflexive.
What is that one?
Reflexive property. Hey, wait a minute. I bet I can go back and say those two are the same too, but what's the reason?
Right angles.
No.
Radius.
No. Definition of a radius, guys.
Wait, is that?
They're both radii
It's not a straight line, okay.
because it's not a straight line through. It's that you can't. Sorry, you can't guarantee that it's a straight line. Actually, it's not. But and I tried drawing it so they weren't straight across. Do you guys recognize that they're right triangles? I have a hypotenuse and a leg. They are congruent because of hypotenuse leg. That means
Okay, yeah.
all the corresponding parts
Are congruent.
are congruent. So guess what? M and N are in corresponding positions. They are the same. This is our problem that we're going to do before we get our homework for tonight. It looks complicated, but it's actually a lot easier than you guys actually will make it out to be. I want you to find X and I want you to find Y, which are here and here. If you know this is 46, can you trace the angle?
Yeah.
It goes to here
Easy peasy.
and to here.
92.
So that means, ooh, what is 92?
The final answer.
What's the final answer? Where?
Well, it's
Minor
y,
art.
y, so it'd be 92 minus 20.
No.
So y. Yeah.
Okay, guys, watch. Getting there, as in partially correct. This is the intercepting arc to that inscribed angle. So this is
92.
92.
That's what I was saying by y minus 20.
Now wait a minute.
Or
Wait
I mean 92.
a minute. Doesn't this A roll down to here and then rolls back over here? Wait a minute. Angle R, we'll call it angle R to make it easier for us. Doesn't that open to the same exact arc?
Whoa.
So isn't that an inscribed angle? And an inscribed angle here has to be what compared to this?
Half.
Congruent.
Half. So now it's back to 46. So you're saying 46 is equal to
X.
x plus 10 because there should be a 46 there. You cannot see that on that drawing. I'll use a different color. But doesn't that mean x equals 36?
Yeah.
Follow the same logic, ladies and gentlemen. Going the other way. I'm going to erase all of this. Follow the same logic.
Y equals
30 opens to PR, which makes that 60. And therefore, I'm going to change colors again.
Angle A is 30.
Angle B,
It's 30.
B has to be 30. So 30 equals y plus 20, or y equals 10 degrees. All I'm doing is using the fact that I have inscribed angles. Inscribed angles are half the intercepting arc, or the arc is twice the inscribed angle. And your homework from lesson 11, page 88, day 1 is 4, 5, 18, and 26. Have a fantastic day.